Okay, who'd like to read? I can't. Thank you. So what do you think we're going to be doing in Module 10? Dividing fractions. Do you think it's the same as multiplying fractions? No. Not really? Any guesses on what you think we're going to do to divide fractions? Okay, I've got turn them into decimals. We're not going to turn them into decimals, no. Right? So when we get to dividing decimals, then that is true. Any other guesses on how we do it? Okay, so you think like with multiplication, we're just going to divide straight across, right? That's probably what I would thought. So we're going to explore some models to see if we can figure out, okay? So it says on page 239, an elementary school receives 5 boxes of minerals for its earth science classes. The 6 science teachers at the school share the boxes equally for their classes. What fraction of a box will each teacher receive? Okay, so we know we have a whole and we have to divide it amongst 6 teachers, right? Well, what is our whole? Okay, our whole is we have 5 boxes, right? Okay, you should be writing those in your book, drawing those in your book. Okay, so if we have 6 teachers, right? It'd be nice if it was just 5 teachers, right? But it's not. It's like what we have here at our school. We have 6 teachers. So what are we going to, how are we going to cut those boxes up so everyone gets equal pieces? Yeah, split it into 6. Why are we going to split all the boxes into 6? So everyone gets an equal amount, right? Okay, go, split yours into 6. Okay, so we've split our boxes into 6, right? How many 6s do we now have? We now have 36, right? 1 6, 2 6, 3 6, 4 6, 5 6, 7 6. And what's this? 12 6, 18 6, 24 6, 36, right? So we have 36 that now needs to be separated amongst 2. 6 teachers. So I'm going to use circles to represent 6 teachers. Okay, so everybody understands that this top portion is the boxes that we're splitting, and our circles represent our what? Teachers. Okay, so now if I put an X in there, what does my X represent? Oh, not one whole box. My X equals 1/6 of a box, right? Okay, so here we go. 1 6, 2 6, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, so I distributed those 1/6 pieces, right? Okay, so the question was, what fraction of a box will each teacher receive? So each teacher has 5 X's, but each X represents what? 1/6. So each teacher will receive 5/6 of a box. Right? Okay. Now we ought to guess out there that if we did 5 divided by 1/6, right? Or 5 divided would be 5 divided by 6. Whoa. Whoa. Right? Because we have 5 boxes and we're dividing it. Divide 6, it would give us 5/6. Okay? Yes. Yep. Okay, third page. Let's see if we can do another. 5 students in the science club prepared for 4 circuit boards for a small satellite called a CubeSat. If they share the work equally, how many circuit boards does each student prepare? Okay, so we want to know how much each student prepares. Okay? So, what do we know?
If there are 5 students.
5 students. Good. What else do we know? 4 circuit boards. Good. Okay? So, how are we going to model this? What is it that's being divided, distributed, given out? The circuit boards. So how many am I going to draw? 4. Everybody draw 4 circuit boards. Okay? Now, what are we going to divide those circuit boards into? 5s. Why? Because there's 5 students. Good. Okay, so we have our 4 circuit boards and we've divided them into 1/5 pieces because there's 5 students, right? So how many circuit board pieces do we have now? We have 24. 5, 10, 15, 20 fifths. So they're cut into fifths pieces. So we have 20 fifths, right? So now we need to take these 20 fifths and we need to give them pieces to whom? To the students. So here are my students, right? And each X is going to represent what? 1/5 of the pieces, right? Okay, go. Distribute out 1/5 pieces to 5 students. Okay, so each student prepares how much? Okay, so there's 4, but are those 4 wholes? Those are 4 1/5 pieces. So if I have 4 1/5 pieces, how much do I have? 4 what? 4/5. Because this is 1/5, 2/5, 3/5, 4/5, right? Okay. So we had 4 boards divided by 5 students equals what? Equals 4/5. Oh, is there something right here that we've learned before? Say it.
4 divided by 5.
Oh, 4 divided by 5. Interesting, right? Is it kind of clicking? That when we look at a model, here's the reason why we do it this way. Good. Okay, let's go on to page 241. Two scientists develop a new substance in a laboratory. They make a total of 5 milliliters. If the substance is shared equally, how many millimeters does each scientist get? Okay, we need to know how many milliliters each scientist gets, right? Okay, what do we know?
There are
2 scientists. Good. What else do we know?
5 millimeters.
5 milliliters. Okay. So what is the thing that we're going to divide up? The 5 milliliters. So how many boxes am I going to show? 5. 1, 2, 3, 4, 5. Okay. So there's my 5 milliliters. What am I going to divide? How many am I going to divide these milliliters amongst? The scientists, right? So what am I going to do to each of my boxes? Put them in halves. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Okay, how many halves do I now have? 10 halves, right? 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves, 9 halves, 10 halves. Does everybody see where I got the 10 halves from? Yes. Okay. I need to go take those halves and distribute them to who?
The scientists.
How many scientists?
2.
2 scientists. There's my 2 scientists. Okay? Each of my X's or dots or however what you want to do, stars, whatever. Each of those will represent what? What will each of my X's represent? A half of a millimeter, right? Okay. That's fine. Thank you. Okay, so let's distribute these half pieces. 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves, 9 halves, 10 halves. Okay? So each scientist will get what? 5 halves. Okay? Well, how much is 5 halves?
2 and 1 half.
Yeah, because what? We have 1 half, 2 halves, 3 halves, 4 halves, 5 halves. So how much do I have in 5 halves? 2 and 1 half. How else could I have changed that improper fraction to a mixed number? Okay, how much do I have? How else could I solve this? 5 divided by 2, right? So 2 times what gives me a number close to 5? 2. 2 times 2 is?
4.
4. Subtract 1. My remainder, thank you, becomes my numerator, and my denominator is my divisor. Okay? Now, how else could I have just seen that then rather than just done a model?
5 divided by 2.
Yeah. 5 divided by 2. How could I represent that as a fraction?
5 halves.
5 over 2. Say it.
5 divided by 2.
Oh, say it again.
5 divided by 2.
Oh, 5 divided by 2. 5 divided by 2. Do you see that relationship? Good. Okay, so today I'm going to get going because today was a late start, so I got to get going in groups. Today, you can either draw it out as a model, or if you can see it and know what's happening and know how to change that division problem into a fraction, you can do it that way. If it asks you to model, model it, okay? Just so that your brain is connecting with those models. And 5 to 5 on how you feel. All right, looks like we got 4s and 5s. Okay, your assignment today is lesson 10.1, front and back then, okay?